Okay, so in this video here, we're going to do some examples of those first order linear differential equations. And we'll start off pretty easy. So let's just solve the differential equation x dy dx is equal to x squared plus 3y, where x has to be greater than 0. Okay, I hope that you wrote down those steps from the last video for solving these things, and we'll just kind of go through the steps. First thing that we need to do is we need to rewrite this because as it is, this is not in standard form. To get it in standard form, the derivative has to be by itself. So I'm going to go ahead and divide everything by x. And then this 3 over x times y is how I'm going to write this one. Because I want the y to be its own term with the function of x out in front. It's still not quite in standard form, because in standard form you have the derivative on the left-hand side, and then you also have the term with the y on the left-hand side. So we're going to subtract that over. Okay, now we're in standard form. The p of x, you don't usually have to write this down, but I'll do it for this example. The p of x is the coefficient as a function of x on y. That's going to be that negative 3 over x. The q of x is that right-hand side as a function of x is just x. Okay, step 2. The next thing that we need to do is we need to find that integrating factor v. And there's just a formula to it. It's e to the integral of p of x dx. So for us, the v is going to be e to the integral of negative 3 over x dx. Okay, and then you just do this integral. So what we're going to do is we're going to pull that negative 3 out of the integral. And then we just have the integral of 1 over x dx, which is a natural log. I am not going to plug a plus c into there, just because you don't need it. And it's not going to help. All right, so the next thing, and this is going to be a pretty common trick, and hopefully something looks familiar to you, but we have this negative 3 multiplied on the outside of a natural log. We're going to bring that in as an exponent. The reason we're bringing this in as an exponent is that way the e and the natural log cancel out, which means that we're just going to get x to the negative 3, or you could rewrite that as 1 over x cubed. So this is going to be my integrating factor. Okay, the next step is we're going to take this integrating factor and we're going to multiply that on both sides of my standard form differential equation, this one here. All right, when you multiply that, we're going to have 1 over x on the derivative minus multiplying it onto 3 over x is going to be 3 over x to the 4th, and then y. Multiplying that on the right-hand side, x times 1 over x cubed is going to be 1 over x squared. The next step, and this always works, so it doesn't matter what the left-hand side looks like, the way that we found this integrating factor was so that we can do this next step here, where we're going to rewrite this left-hand side as the derivative of the integrating factor, which was the 1 over x cubed times y. You can double check to make sure it works, but you don't have to because it will always work as long as you found the integrating factor correctly. It would be the first, 1 over x cubed, derivative of the second, dy dx, plus the second, which is the y, times the derivative of the first. The derivative of 1 over x cubed would be negative 3, 1 over x to the 4th, which is what we have here. Okay, and I'm just going to copy the right-hand side now. All right, the next step is to integrate both sides. When you integrate the left-hand side, it just cancels out that derivative. When you integrate the right-hand side, for now, I'll just write that as 1 over x squared dx. But we can go ahead and figure out what that is. You can think of this as the x to the negative 2. That negative 2 is going to go up to negative 1, and then we divide by negative 1, and we get negative 1 over x. At this point, you are going to have to include the plus c. Do not forget that plus c. If you forget it, it'll mess up your whole thing. The last step is that we're trying to get the y here by itself. To get that y by itself, I have to get rid of this x cubed in the denominator. So we're just going to multiply both sides by x cubed. So here we're going to have the y on the left-hand side. X cubed times negative 1 over x is negative x squared. X cubed times c is just going to be cx cubed. And this is the solution to my differential equation up top. And you can double check by plugging it in. Take this function and plug it in to the original differential equation that you have, and I promise you that it'll work out. Okay, we'll do maybe one more of these examples in this video. Find a good one. I guess we'll do this next one. It's a pretty long one, so here we go. Example. Solve 3xy prime minus y is equal to the natural log x plus 1. X has to be positive, and we're given a set of initial conditions. Y of 1 is equal to negative 2. All right, this is no longer called solving a differential equation. Now it's called an initial value problem because you're given these initial conditions. What these initial conditions allow us to do is at the end, we can find the c. Okay, so let's just get started. First things first, this is not in standard form, and we have to make to be in standard form. We're going to do that by dividing everything by 3x. So we get the y prime, that derivative by itself. When I divide 3x onto the y, I'm going to rewrite that as 1 over 3x times the y. On the right-hand side, there's not really too much I can do there. I'll just leave this as natural log x plus 1 over the 3x. Okay, now it's in standard form, where the p of x is this negative 1 over 3x, and then the q of x is all this stuff on the right-hand side. Next step is we want to find the integrating factor v, and we get that by integrating, e to the integral of p, which was negative 1 over 3x dx. We're going to do the same thing here. So we're going to pull out that constant, that negative 1/3, and then we have the integral of 1 over x dx. That's going to be a natural log. Do not put the plus c up top here. We're going to move that negative 1/3 and as the exponent on the x, and then the e and the natural log cancel out. So x to the negative 1/3 is going to be my integrating factor this time. What I'm going to do here is I'm going to go ahead and skip step 3 because it's not really important. I'm going to kind of combine 3 and 4 together. Remember that the whole point is that this integrating factor is multiplied onto the standard form of your differential equation, and then the left-hand side you can just automatically rewrite as the derivative of this integrating factor times y. So there's no point in even multiplying it onto the left-hand side because you're just going to rewrite it like this anyway. You are, however, going to have to multiply that onto the right-hand side. Multiplying x to the negative 1/3 onto the right-hand side, I'm just going to leave this numerator alone and multiply it onto the x in the bottom. Now it's going to be an x to the 4/3 instead. Okay, now we're going to have to integrate. And this is not going to be a fun integral to do. The left-hand side is fine. Remember, that just cancels out the derivative. But then we have to do the integral of natural log x plus 1 over 3x to the 4/3. We could pull this 1/3 out, and we might want to do that. All right, and now you want to go through all the different techniques that we saw in Chapter 8 of how to do this integral. In this case, we're going to be doing integration by parts. Pretty much any time you have a natural log, integration by parts is the way to go. So we need to set up our u and our dv. Remember, with natural logs, you almost always want the natural log part to be the u. So I'm going to let u be natural log x plus 1, which means that dv, I'm going to write it as x to the negative 4/3 dx. Okay, then we have to find the derivative of u. The derivative of natural log is 1 over x. The 1 just goes to 0. The antiderivative of v, so x to the negative 4/3, that negative 4/3 is going to be increasing by 1. So that's going to go to negative 1/3, and then we're going to divide by that negative 1/3. So we get negative 3, and then it's going to be x to the negative 1/3. All right, and then remember that integration by parts is uv minus integral v du. We have to be a little bit careful here because we did have this 1/3 out in front. So that 1/3 is still in front, and then it's u times v. I'll write that as negative 3x to the negative 1/3 times that natural log x plus 1. And then minus the integral of v du. So we're going to get that negative 3. And then 1 over x times x to the negative 1/3 is x to the negative 4/3. Okay, looks pretty awful, but let's do that other integral now. It's doable at least. So I'm just copying all of this down. Here the double negative cancels out to be positive. Negative 4/3 is going to go up to negative 1/3, and we're going to divide by another negative 3. So I already have a positive 3 out in front. I'm going to multiply by another 3, and it's negative. And then that negative 4/3 goes to negative 1/3. At this point, we'd want to include the plus c. Okay, we can go ahead and multiply that 1/3 onto all of this stuff, and then don't forget we still have this left-hand side over here. So that left-hand side was the x to the negative 1/3 times y. My right-hand side, after distributing the 1/3, is going to be negative x to the 1/3 natural log x plus 1 minus 3 x to the negative 1/3 plus c. Trying to get the y by itself, we want to get rid of this x to the negative 1/3. To do that, we're going to multiply everything by x to the 1/3. I forgot my negative sign. This is supposed to be x to the negative 1/3 out in front here. Okay, so multiplying everything by x to the 1/3. They cancel out here, so you're still going to get that negative sign. And we might as well distribute that negative sign into the parentheses, so we're going to have natural log x minus 1. X to the 1/3 onto this next term, again cancels, and we're just going to get a negative 3. Do not forget to also divide the v onto the c. So we're going to get that c and then an x to the positive 1/3. All right, last little step here. Oh no, sorry, we still have the initial conditions, but we can combine the negative 1 and 3 together. So the last thing is that we can find the c using those initial conditions up top. And if you remember, or if you have it written down, the initial condition up top was y of 1 is equal to negative 2. So we just plug that in. So my y is going to be negative 2. And if I substitute in x to be 1, natural log of 1 is just 0, minus the 4, plus c. And if I'm plugging in 1 for the x here, 1 to the 1/3 is just 1. So if I add the 4 over, I get 2 is equal to c. And then plugging the c back in, I get my final answer. Y is going to be negative natural log x minus 4 plus 2 x to the 1/3 is now the solution to that differential equation, that initial value problem that we started with.